Yes, sir. A very good morning, students. So we have taken our third unit where we do have three topics actually: step up chopper, step down chopper, and step up down chopper. So these three topics we are supposed to deal with the derivative part, and exactly we have to do the problems on these three topics. We'll see the syllabus later on also. So first, last class, what we have done, we have taken the step down chopper, and especially these choppers are used wherever we are having the battery operated devices, that is in smartphones, in the laptops, even in battery operated electrical vehicles. So power electronics main application is how to design and develop the electrical vehicle system and electric train system. So we concentrate on these particular products with the help of the choppers. So we have seen step down chopper and step up chopper operation last class. Step down chopper always output voltage equal to alpha or del, as we are use the alpha for the firing angle. It is del into Vs. This is the derivation, simple two lines which you have seen. Today's class, we first discuss regarding the step up down chopper or buck boost chopper. Let me share that slide right. So any circuit, if you see, you must be in a position to give the explanation. So what is, we have seen the circuits of step up as well as the step down chopper also. Is the voice is audible? Anyone student unmute and please confirm.
Yes, sir.
Right, good. Right. So, power electronics, how to score the maximum marks, we should represent only the current direction rather than the theory statement. So, today's class, we take the step up down chopper circuit and what is its explanation. Right. So, this is the circuit. And once again, I am mentioning, if you are joining any company based on power electronics, you are supposed to design and develop the new circuit. That will be your job. How to convert fixed DC to variable DC power. Right. So these circuits are used only for the educational purpose. You should think how I can turn on the SCR and how I can turn on the SCR or any type of switch. Now we got this circuit for the examination in the sense. Right. So this circuit acts as the step up down chopper. So what is the operation? So case one is we are giving firing pulse to the chopper with the help of UJT and the chopper is turned on. Therefore, case 1, chopper is on, supply is on. Okay. When the chopper is on, what is the explanation we are supposed to see? So when the chopper is on, direction of the current starts from V plus to chopper to the inductor. The current cannot flow here because if the current entering which terminal of the diode? Cathode terminal. So if the current enters the cathode terminal, the diode is turned off. It will be open. Therefore, 100% of current flows through this particular loop only. And you see, in all the circuits, we find the inductors. Inductor has to store the energy. We should design the circuit in such a way that inductor should store the energy when the supply is on, and inductor has to release that energy when the supply or chopper is turned off. Inductor has to release that energy to the load. Okay, that means in simple statement, with the help of inductor also we can run the load in the absence of supply also for short period of time. Now what is case 1? When the supply is on, with chopper on condition, the direction of the current flows from V plus to CH and CH to inductor and from inductor to V minus. Since current cannot flow through this diode. So this case 1 circuit is shown here. You can see it is the direction of the current. During this process, same words as it is you have to write for the full marks. When the supply is on, direction of the current starts from V plus to chopper to inductor to the V minus. During this process, when the chopper is on, inductor stores energy in the form of magnetic field, or inductor energizes exponentially. We have already seen the graph for that one. So you can see here, inductor is energizing, current is entering this terminal, here it will be positive and here it will be minus. Okay. During this process, inductor energizes. So when the chopper is on, energy is not transferred to the load. This is the most important point. Chopper is on means it is just like a wire, here you can see. And when the chopper is on, through this circuit, we are not able to transfer the energy to the load. So when the chopper is on, energy is not transferred to the load. 3 points are quite sufficient. When the supply is on, direction of the current starts from V plus to chopper, chopper to inductor, inductor to V minus. During this process, inductor energizes and stores energy in the form of magnetic field. When the chopper is on, inductor energizes and energy is not transferred from source to the load during step up down chopper operation. Now let us come back to the case 2. Okay, right. Case 2, with the help of forced commutation circuit when the chopper is turned off. Okay, so case 2 starts, what happens when the chopper is turned off? Now you can ask one question, sir, why I have to turn off the chopper? Okay, imagine chopper is used inside the laptop or in your smartphone. Okay, when you are supposed to shut down your smartphone or the laptop, what you are going to do? You are going to directly turn off your supply? No, you got one particular protocol where you are going to use the option shut down or else any software option. So there we are going to turn off the chopper. Even in electric train also, in order to stop the electric train, directly we never remove the power supply. We turn off the power electronic component. So that's why this condition we are discussing. So case B, when the chopper is turned off with the help of forced commutation circuit, what's going to happen? When chopper is turned off with the help of forced commutation circuit, the inductor starts to de-energize or release its stored energy. Okay, you can see here. Now, what is the basic difference between inductor and capacitor operation? Inductor changes its terminals potential when it is energizing and de-energizing. For capacitor, it will be remaining same because the voltage it is related. Now, so when inductor is de-energizing, when the chopper is off, inductor starts to de-energize. When inductor de-energizes or releases the stored energy, the terminals or the potential across the inductor gets reversed. The potential across the inductor gets reversed. As you can see, here we are having the positive terminal and negative terminal. Okay, this is the most important point. So case B, when the chopper is off, inductor starts to de-energize, the potential across the inductor gets reversed. Now the direction of the current starts from, any guesses anyone? Now the direction of the current starts from L plus to load, and from load to, now the current flows through the diode, it is entering anode terminal, now the diode is on. So L plus to diode and diode to the L plus to load, load to diode, and from diode to the L minus. So now what we can say, when the chopper is off, the energy from the inductor is transferred to the load. Now energy is transferred to the load, load is on. So what is the explanation? When the chopper is on, output voltage is 0, you can say, because energy is not transferred. When the chopper is on, output voltage is 0. When the chopper is off, output voltage has the value which is equal to the inductor voltage. So why we have placed the capacitor? Only to provide constant voltage to the load. No need to give any clear explanation for the capacitor, that's enough. Okay. So across the load, if I am not getting a constant voltage, okay, so what we have to do? We are supposed to add one capacitor in parallel with the load. So capacitor provides the constant voltage. So I repeat the explanation. Step up down chopper theory is this one only. Okay, then we got the derivation. We see the derivation also. Case B, when the chopper is off with the help of forced commutation circuit, the inductor starts to release the stored energy, or inductor de-energizes. When inductor de-energizes, the potential across the inductor gets reversed. So inductor de-energizing current starts from L plus to load, from load to the diode, diode is on, from diode to the L minus. During this process, when chopper is off, energy is transferred from inductor to the load and the load is on. So when chopper is off, the load is on. So any motor is connected in the place of load, the load starts to rotate because of this operation. Now case 1 and case 2, that's enough. Okay, I hope everybody understood that current direction only we have to represent. Now we move to the derivative part. What derivation we have to show? So as inductor is storing the energy, okay, inductor storing the energy, inductor is releasing the energy. We have to take up the derivation. So I'll maximize the screen. Okay. Right. So working of step up down chopper, this derivation is important. You can see, you can practice this one, which can step up as well as step down. When chopper is on, the energy is stored in the inductor. Just know what we have discussed. So energy travels from V plus or VDC to chopper, chopper to inductor, and V minus. Direction of current is shown every time we have taken. When chopper is switched off, in case B, when the chopper is turned off, current flow, inductor starts to de-energize. You can see voltage across the inductor. We know the formula L into di by dt. As the direction of voltage across inductor reverses, okay, you can also from L plus to load, load to diode, and diode to L minus. We have to keep here L plus and L minus. So during case 1, what's going to happen? Inductor is storing the energy. What is the formula for power? Power equal to voltage into current. But what is the formula for energy? Energy is represented by W. Energy is equal to power into time. Therefore, what is the power formula? Voltage into current. So VDC into I, if the input supply is DC. So energy stored by the inductor, Wi is taken, equal to VDC into current into T on, because when the chopper is on. And now what is the second case B? Case B, energy is released by the inductor. So energy released by the inductor is W not equal to voltage. This is not volume, this is the voltage, that is output voltage, V naught. So when energy is released by the inductor, V naught into current, V naught into current into T off, because when the chopper is off. So according to ideal condition, if the system is there is not having any losses, this derivation is derived understanding the ideal condition. So energy stored is equal to energy released by the inductor. Therefore, we write here energy stored by the inductor equal to energy released. So what is energy stored? Voltage into current into under chopper on condition, and voltage into current into under chopper off condition. If you simplify, I get cancelled. V is equal to T on by T off into VDC. Okay. But I want the expression in terms of the duty cycle. What is the definition of duty cycle? We have taken del. Del is equal to T on by T, where T is the combination of T on plus T off. So V naught is equal to T on by T off. T off we can also write. So as T on plus T off is equal to T. So T off is equal to T minus T on into VDC. So again you can take T on common. So what's going to happen? After 1 into 1 by T on minus 1, you can check this one. So as we know, T on by T is taken as the del. Here in this slide we are using as K. Remember, throughout the subject, firing angle alpha for converters. For choppers, what is the variable through which we can control the speed and power? It is the del. Okay. So T on by T is nothing but del. Therefore, we are putting the T on by T is nothing but, here this represented by K here, but actually we can represent by del. Okay, right. So what is the expression we obtain? Output voltage V naught is equal to del by 1 minus del into VDC, input voltage. So what is the step down chopper expression? Step down chopper expression is output voltage equal to del into input voltage. But what is step up chopper, step up down chopper? This one, okay, step up down chopper. I'll come back to the step down, step up chopper. See, yesterday I've just mailed the material step up chopper to the entire BTech third year students email ID. You can check that one, but still we'll take. So what is the expression now? V naught equal to K by, that is all del by 1 minus del into VDC. Okay, don't forget step up down chopper. What is the output voltage expression? V naught is equal to del by 1 minus del into VDC. Okay, so always the del value is less than 1. We already know chopper works as step down. You can see in the range V naught is less than, output voltage is less than VDC, it acts as step down. When output voltage is greater than VDC, it acts as the step up. Next class we take the problems, you will understand. Okay, so remember this expression and simple the derivative part. Let us go back to this slide here. So now today's class, the topic which we are taking right now, the next topic. So this derivation, if you see, step up chopper, also we got the derivation where it is similar expression. This is mailed to your mail ID, complete material. See, in what way we have to do the derivation for step up chopper also. So energy stored by the inductor during on condition and energy released by the inductor. So for if you see the same thing, energy stored equal to energy released. So the same expression V naught is equal to, here you can see it is not alpha del. V naught is equal to 1 by 1 minus del into Vs for step up chopper. So don't get confused. For step up down chopper, V naught equal to del by 1 minus del into Vs. For step up chopper, V naught is equal to 1 by 1 minus del into Vs. This derivation you can see, I just mailed that one, complete derivation, the similar one as we have taken for step up down chopper. So every student should be clear with these three formulas. Step down chopper derivation is this one. Step down chopper output voltage equal to del into input voltage. Okay, del into input voltage. Step up chopper, what is the expression? Output voltage equal to 1 by 1 minus del into input voltage. And what is the derivation for the expression for the step up down chopper? V naught is equal to, that is output voltage equal to del by 1 minus del into input voltage. Okay, is it clear? So step up chopper, what is the expression, anyone? V naught is equal to 1 by 1 minus del into input voltage. Step up down chopper is V naught equal to del by 1 minus del into input voltage. Okay, right. So if you see the syllabus, they are mentioned complete analysis for step down chopper, step up chopper, and step up down chopper. Okay. So now we are taking the new topic in the chopper. Problems we'll see later on. Right. Next class. 4-quadrant operation of the chopper. So all students, this is the expected question. Direct theory 1. 4-quadrant operation of the chopper. So in simple language, what is just a 4-quadrant? The word 4-quadrant operation means making the machine to act as motor, to act as generator in forward and in backward direction with the help of power electronic circuits. Only dual converters and choppers are used in 4-quadrant operation. This word is you can write anywhere. Okay, 4-quadrant. Why we are supposed to study 4-quadrant? What is the meaning? If the machine is acting as the motor, it is single quadrant. If the machine is acting as motor and generator, it can be explained in 2 quadrants. If the machine is acting as motor and generator and rotating in forward direction as well as in backward direction, so 4-quadrant operation is what we use the technical word. So 4-quadrant operation can also be done by the choppers. So what is that circuit? Show me that circuit which will make the motor to act as generator and to rotate in forward direction and in backward direction. So where we use this application in the lift system, remember 4-quadrant means lift. So you can see here, 4-quadrant chopper, it works in forward motoring. That is, electric train is moving in one direction, clockwise direction. Forward regenerative braking mode. That means when you apply the braking to the electric train, electricity is generated, the motor acts as the generator. Okay, remember this one. So what is this word braking? That means the motor which is used inside the electric train, when we apply the brakes to the electric train, during that process also the motor will act as the generator and will generate the electricity. So that electricity, few times it transferred back to the source and it is again transferred to the load. So we are having forward and backward. So a machine can be operated as motor and generator. Here regenerative means it is the generator. Okay, in forward and backward direction. That's why the entire behavior of the motor is represented in 4-quadrant. So what is that circuit? Chopper circuit. Already I mentioned chopper is a thyristor on-off switch which is enclosed in a square bracket or rectangle bracket which represents the forced commutation circuit. Okay, now, so we can use the chopper elements MOSFET, BJT, IGBT, SCR. So 4-quadrant chopper drive. This theory only will be there, but if you understand, you can explain any type of circuit. Come on. So 4-quadrant chopper circuit contains 4 choppers, and in parallel, anti-parallel. You can see always these diodes are connected in anti-parallel. Anti-parallel means here what? You can see the cathode is connected to the anode of the SCR, for example, and the anode of diode is connected to the cathode. So we got 4 choppers in anti-parallel to each chopper, one particular diode. So what is the use of this diode? We'll discuss. Okay, this particular diode. So we got the motor. Examination also. In competitive examinations, they will ask you this particular topic only. So if motor is given using power electronics, how can you control the speed of the motor? How can you make the motor as generator and explain the lift operation or explain the electric train operation? So you can explain using this particular circuit. So we got the motor, and every motor has got the windings. This is Rle load. Motor back EMF is also taken into consideration. Okay. Explain the chopper operation with Rle load means this circuit asked is you can give the explanation for 4-quadrant. So inductor provides the continuous current. Inductor is the external inductor. Very large values of inductor provides the continuous current. Okay. That's why we place additional external inductor. And we got armature resistance. Armature resistance, armature inductance plus external inductor to provide the continuous current. These words, simple lines we have to put in the examination. L is equal to external inductor plus armature inductance provides the continuous current operation. We are not discussing discontinuous current operation as per our syllabus. In the textbooks, they have mentioned discontinuous current derivations. Please don't get confused. Okay. Now, this motor, first I want to rotate. So case 1, all students listen here. Case 1, what's going to happen? Okay. So that means you are starting the electric car or lift or electric train. Here they have taken separately excited motor. Separately excited motor, they are having separate field windings and armature windings. Okay. You can also take the series motor also without these windings. Right. So how many choppers we are taking? 4 choppers. Okay. Case 1, we'll take the explanation. Case 1, 4 choppers we have taken, and why we are using these diodes we'll see. Okay, freely wheeling diodes, of course you can use. Case 1, anybody ready now? Case 1, you see all of you. Case 1. So this explanation you don't get anywhere in any textbook with clarity. Listen carefully. Case 1, when the supply is on, direction of the current starts from V plus, and firing pulses are given only to CH1 and CH4. Firing pulses are given to only CH1 and CH4. Okay. So only CH1 and CH4 are turned on with the help of UJT pulse. Remaining CH3 and CH2 are off. They are not given the firing pulse. So case 1, CH1 and CH4 are turned on. They are given the firing pulse. So when the supply is on, direction of the current start from Vs plus to chopper CH1, CH1 to load. Okay, CH1 to load, and from load to the CH4, CH4 to the V minus. You can see the operation. So when there's forward motoring, that means I want to rotate the motor, accelerate the motor, start the electric train. What we have to do? So you can see current start from Vs plus to CH1, CH1 to the load, and from load to the CH4, CH4 to the Vs minus. So what is the statement we have to write? Case 1, when the CH1 and CH4 are on, direction of the current start from V plus to CH1, CH1 to the load, and from load to CH4, CH4 to the V minus. Any student, any doubt is there, you can unmute and you can ask any not understanding part, because this is the tough circuit. Okay. So now, during this process, inductor energizes. During this process, inductor energizes, and inductor energizing terminals are, this is positive and this will be negative. Okay. During this process, inductor energizes, and inductor stores the energy in the form of magnetic field in an exponential manner. So first motor rotates. Now what is the statement? case 1, when the supply is on with CH1 and CH4 are turned on, direction of the current start from you should show the direction of the current in the examination. 4 different circuits. V plus to CH1, CH1 to the load, and load to the CH4. Yes, Monica raised hand. Any question is there? Unmute and ask me the question. Right.
Sir.
Cheppandi. Cheppandi, Monica.
Let sir, let.
Okay. So V plus to CH1, CH1 to the load, and from load to the CH4, CH4 to the V minus. Direction of the current. During this process, inductor energizes. Inductor stores energy in the form of magnetic field. During this process, motor accelerates, motor develops the kinetic energy and rotates in forward direction. Forward direction is the assumption of engineers. When the motor rotating in clockwise direction, right hand side, we assume it is called as the forward direction or forward motoring. Okay, right. So during this process, inductor energizes, motor accelerates, motor rotates in clockwise or forward direction, motor develops the kinetic energy. These words you have to keep in your explanation, which many textbooks have failed. You can study any power electronics textbook. When the inductive load or especially the motor is present, these words are missing. But what industry people require, this explanation they require. When the supply is on, the direction of the current we have mentioned. During this process, inductor energizes. This will be positive and this will be negative terminal for the inductor. During this process, the motor develops the kinetic energy. Motor accelerates in forward direction and rotates in forward or clockwise direction. Okay. So this is called the first quadrant operation. Motor is rotating now. So let us check what happens next. You can see the direction of the current in the animation. Okay. So current flow we have shown here. Current is flowing the chopper to the load, and from load to the next chopper CH4, and CH4 to the next one. So people have designed with 2 choppers operating to run the motor. Okay. Let us take this one. Here, as I mentioned, inductor energizes, is the voltage. Okay, right. So what happens next? You can see, as I mentioned, what is the explanation? 4 quadrant behavior. Motor is rotating. Okay. Now we take the next explanation. In the same case 1 only. Now you can see inductor which is already energized. When inductor is energized completely, once again it starts to de-energize. So what is this here they have mentioned? So now, what is the second case? CH1 operated, CH1, CH4 are on. Okay. Now we are turning off this CH1 with the help of forced commutation circuit. We turn off this CH1 and we turn on the remain CH4 on only. Okay. So what's going to happen? Case 1 only. After certain period of time, inductor starts to release the stored energy. Inductor voltage is greater than the back EMF voltage of the motor. Therefore, energy travels from inductor to the motor. Okay. So, after certain period of time, inductor starts to de-energize. It releases its stored energy. During this condition, inductor voltage is greater than the back EMF voltage. Therefore, with chopper 1 off condition, when chopper 1 is off, no input energy is transferring the circuit. The entire energy is released by the inductor. Okay. So, inductor de-energizes. The de-energizing current is from L plus. This will be L plus. L plus to motor. That we can write the motor to CH4, because we are turning off only CH1 is off, CH4 is on. And that energy released by the inductor, always it has to come back to the inductor itself. Therefore, current flows from L plus to motor to chopper CH4, and CH4 to which diode now? D2, and from D2 to the inductor through the resistor. Okay. So you can ask, sir, what is this operation? Is it useful? Yes. When the electric train is moving at very fast condition at its rated speed, you can also turn off the chopper and you no need to use the input supply for short period of time. You can use the inductor to rotate the motor in the same direction. That means I am saving my input electric energy. This is a cost effective system. So when electric train is started and it is moving at rated speed, the inductor stored energy is responsible to rotate the motor in the same direction. So without using the supply also for short period of time, we can run the motor in the same direction. That is the advantage. That's why this is very important. So when the supply is on, in case 1, inductor energizes. When inductor de-energizes, after certain period of time, inductor starts to de-energize. The de-energizing current starts from L plus to motor, because motor back EMF voltage is less than the inductor voltage. Current flows from inductor to motor, motor to chopper 4, chopper 4 to D2, D2 to the L minus. So this is used to run the motor in the absence of the supply also. That means how to turn off the supply? I will remove the power supply terminals. No, we will turn off the chopper 1. So this is case 1. Here we have seen motor is rotating in forward direction. Okay, right. So let us take the next operation. So next operation is what? This is very interesting, very important here. You can see here. We'll explain here. Just wait a minute. Next operation will be how to transfer the energy from motor to the source. Let us say I'm applying the brakes. Now I want to stop the electric train. Okay, this is what just now what we have discussed. Energy travels from inductor to the chopper, chopper to the diode, and diode to the back to the inductor. This is what we have discussed. So now we are moving for the next operation. We will just move. So now, what is this next operation? Okay, case 1 only. So what we are going to do, we'll discuss here. It is not the right. Now we go for the case 2. Case 2 is what? Making the motor to act as a generator. Okay. Imagine electric train is approaching one station and we are applying the brakes to the electric train. We are supposed to stop the electric train. Okay. When electric train has to be stopped, electric braking is created. So during the electric braking, the motor acts as the generator. That is, during this condition, the back EMF of the motor will be greater than the energy across the inductor, because the inductor has already released its stored energy. Inductor voltage will be less than the back EMF of the motor right now. Okay? So when electric train is approaching a nearby station, electric braking is used to stop the electric train. During this process, the motor inside the electric train will act as the generator, and the motor back EMF voltage will be greater than the inductor voltage and the supply voltage. Inductor voltage and the supply voltage. Therefore, energy starts to travel in opposite direction or reverse direction from motor. You can see here this will be plus. Therefore, now the current starts to flow from generator, the motor which is acting as the generator. That means if I am stopping the electric train, at that time also I am generating the electricity. How it is possible? So energy travel reverse, current direction of the current gets reversed. It travels from plus terminal here. That is, you can mention here from the generator G to inductor. Inductor to, now we are turning on the chopper 2 and turning off the chopper 4. Here switch is off. Here it is on. From inductor, from generator to inductor, inductor to chopper 2, and chopper 2 to next diode D4 is on, and from D4 to the negative terminal of the generator. You can see. So when electric train is about to stop, we make the motor to act as generator. Current flows from the generator to inductor, inductor to the chopper, and new chopper, and chopper to the diode D4, and from D4 to the motor. You can see this one. This is called the braking condition. When you are applying the brakes, the main advantage of power electronics is when any electric vehicle is about to stop, during that process, the motor is made to run as the generator. Its voltage is greater than the voltage across the inductor and supply voltage. So now you can see energy is transferred from generator to inductor, inductor to chopper, and chopper to this one. This is what we say the generating action. You can see here. stored energy, and D for this is what generating here. You say the machine is acting as the generator. Okay. So this is the case 1. Case 1 says that energy is traveling from source to load, inductor is de-energizing, and when the electric train is about to reach any nearby station, electric braking is created. When electric braking is created, the motor acts as the generator and energy travels or current flows from G plus to generator, positive terminal, G plus to inductor, inductor to chopper CH2, CH2 to D4, D4 to the back to the generator. So in this way also, when we are stopping the electric train, we generate the electric energy. So this is what happens here. So now we move to the case 2. This will be a tough topic, okay, but still based upon the requirement, we take number of times even in the next class if you are having the requirement. But exact correct explanation, simplified explanation, listen in the class and making your own current direction with different circuits. 3 circuit current direction you have to show, okay, while explaining. Now let me go back, take to the next case, okay. Now you see case 2. Case 2 is what? Reverse motoring. This is forward motoring. Third quadrant is reverse motoring. That means I want to move the electric train in backward direction. Understood all of you? In a railway track, electric train moves in forward direction and same electric train has to move in backward direction. How it is possible? So now we say the direction of the current flow in the circuit is reverse. That means case 2, all of you. Now case 2 starts with CH1, CH4 are off and CH3 and CH2 are turned off with the firing pulse. Case 2 starts with, case 2 is CH3 and CH2 are given the firing pulse and both are turned on. CH1 and CH4 are off. So what is the direction of the current? Anyone? Any guesses? What will be the direction? Yes, here you can see the circuit. One student unmute, you are getting the disturbance. Right. When the supply is on, case 2 I am discussing, when the supply is on, direction of the current flows from V plus to, as CH3 and only CH2 are on, V plus to CH3, CH3 is on, CH3 to the load and load to the CH2 and from CH2 to the V minus. You can see in the animation CH1 and CH4 are off. Okay, let me take the attendance first. Here, last 1 minute is there.